All right, everyone, get ready, because
Okay.
today we are going deep into vector databases.
Vector databases.
Yeah, you know those things that you keep hearing about
Yeah.
that are going to revolutionize how search engines work and AI and all that?
Right.
I've been seeing the hype too, and companies like Google and Meta are putting tons of resources into it.
Mm-hmm.
So we really need to figure out what's going on here.
Yeah, well, you're right to be curious.
Yeah.
It's not just hype. Vector databases really are a game changer, especially when it comes to interacting with information.
Oh.
You see, traditional databases,
Right.
they work great for neatly organized data,
Uh-huh.
your classic rows and columns.
Yeah.
But so much of the data that we're generating today is unstructured, like images and text and audio,
What?
things that don't fit nicely into those rows and columns.
And that's where vector databases come in.
That's exactly it.
I mean, I love using Spotify, and their recommendations are usually spot on.
Yeah.
Are those powered by vector databases?
You got it. Think about how Spotify figures out what songs you might like.
Okay.
They analyze things like the genre, the tempo, the instruments used,
Yeah.
a whole bunch of other characteristics of the songs you already listened to.
Yeah.
Then they find other songs with similar characteristics to recommend to you.
Right.
But to do that efficiently, they need a way to represent all those song characteristics in a way that a computer can understand.
Right. That makes sense.
Yeah.
But how do they do that?
Right.
I mean, how do you turn something like the mood of a song into data
Yeah.
that a computer can work with?
That's the really clever part.
Okay.
Vector databases use something called embeddings to represent complex data as numerical vectors.
Okay.
Imagine plotting points on a graph.
Yeah.
Each point has coordinates that tell you its location.
Yeah, I remember that from math class.
Exactly.
Yeah.
Now imagine each point represents a song, and the coordinates represent different characteristics of that song.
Oh.
Things like tempo, genre, and even mood. These coordinates form a vector that represents that song in a multidimensional space.
Okay.
It's like a fingerprint that captures the essence of the song.
So each song becomes a point in this multidimensional space based on its characteristics.
Got it.
Kind of like a map of all the songs.
You got it.
Okay.
And the beauty of this is that the vector database can then find songs that are close to each other in this multi-dimensional space.
Right.
Songs that are close to each other share similar characteristics.
Yeah.
So it's a really effective way to find songs you might like.
Based on what you've already listened to.
Based on what you've already listened to.
So instead of searching for exact matches like a traditional database,
Right.
vector databases find items that are similar.
Exactly.
Based on these vector representations.
That's a really cool idea.
And this is a huge deal because it allows us to do things that were previously impossible with traditional databases.
Yeah.
We can search for images that look similar.
Find documents that are related by meaning even if they don't share the same keywords.
Oh, wow.
And even create those personalized recommendations we were talking about.
That's incredibly powerful.
Yeah.
Okay, I'm starting to understand why everyone is so excited about vector databases.
Yeah.
But let's talk about the actual mechanics of it all.
Sure.
How does this similarity search actually work?
Well, the process starts with a query.
Yeah.
Let's say you want to find songs that are similar to your favorite song.
Right.
Your favorite song is already represented as a vector in the database.
Okay.
So your query finds similar songs, also gets converted into a vector.
Wait, hold on. How do you turn a query, find similar songs into a vector?
There are pre-trained models,
Okay.
like the one that powers your favorite facial recognition app,
Yeah.
that can turn words and phrases into vectors.
Okay.
Think of it this way. Each word or phrase is assigned a set of coordinates based on its meaning and how it relates to other words and phrases. These coordinates form a vector that represents the query.
Right.
It's like creating a fingerprint of your question.
So basically, both the data in the database and the queries we use to search that data get turned into vectors, which allows the database to compare them and find similarities.
Exactly.
Okay, I'm following so far.
The database then calculates the distance between the query vector and all the other vectors in the database.
Okay.
The closer the vectors are in this multidimensional space, the more similar the items are.
I see.
Yeah.
It's like finding the closest points on a map.
Exactly.
Instead of a map of cities, it's a map of all the data points in the database.
That's a great analogy.
Yeah.
And because these databases are specifically designed for this type of similarity search, they use really clever algorithms to do these calculations incredibly quickly.
Okay.
Even when you're dealing with millions or even billions of data points.
This is all incredibly fascinating.
Yeah.
But I have to admit, I'm starting to feel a little overwhelmed by all the technical details.
Right.
Are there any real-world examples?
Oh, absolutely.
That can help me wrap my head around this?
Yeah.
I mean, aside from the Spotify example, of course.
Let's talk about something everyone struggles with.
Okay.
Search engines.
All right.
We've all been there. You type in a query, but the results aren't quite what you're looking for.
Yeah, for sure.
Traditional search engines mostly rely on matching keywords, which can be very limiting, especially when you're dealing with complex topics or trying to express a specific intent.
You mean like when I search for sad songs?
Yes.
And I get a bunch of songs with the word sad in the title?
Exactly.
But they're not actually sad songs.
Exactly.
Right, yeah.
That's where vector databases come in.
Okay.
They power something called semantic search.
Okay.
Which is all about understanding the meaning behind your search query.
Right.
Not just the words themselves. So a semantic search engine powered by a vector database would be able to understand that you're looking for songs that evoke a feeling of sadness.
Right.
Even if they don't explicitly use the word sad.
Okay, that's starting to click for me.
Good.
So instead of just matching keywords, it's understanding the concept of sadness.
Yeah.
And finding songs that are close to that concept in this multidimensional space we've been talking about.
Precisely. And that's just one example.
Okay.
Vector databases are also being used to improve the accuracy of large language models.
Right.
Like the ones that power chatbots and AI assistants.
All right.
They do this by giving these models access to vast knowledge bases that are organized using vectors.
Right.
It's like giving them a superpowered memory boost, allowing them to access relevant information much more effectively.
So you're telling me that my interactions with chatbots could become much more natural and intelligent?
It is.
Thanks to vector databases.
Yeah.
That's pretty exciting.
And it goes beyond just text. We're also seeing applications in image search where you can search for images based on their visual content rather than just keywords.
Wow.
Imagine searching for pictures of cats playing with yarn.
Yeah.
And actually getting results that accurately reflect that query.
That would definitely make finding the perfect cat meme a lot easier.
Exactly.
So these are just a few examples.
A few examples, yeah.
We're just beginning to scratch the surface of what's possible with vector databases.
Yeah, we really are.
It sounds like we're moving towards a much more intuitive way of interacting with information, where computers are able to understand our intent and provide us with truly relevant results.
For sure.
But with all this talk about massive databases and complex algorithms, I can't help but wonder, is this technology only accessible to big companies with tons of resources?
Right.
Or can regular folks like me actually get their hands dirty and build something with vector databases?
That's a great question.
Yeah.
And the answer is surprisingly accessible. Platforms like Pinecone are making it easier than ever for developers to build applications using vector databases.
Okay, so walk me through this.
Okay.
What would it actually take to build, say, a simple application using a vector database?
Right.
Let's say I wanted to create a search engine for my personal document library.
Well, in that case, you'd start by choosing a vector database platform like Pinecone.
Okay.
These platforms handle a lot of the heavy lifting for you.
Okay.
So you don't need to be an expert in database management to get started.
Got it.
Then you would need to get your documents ready for the database.
What does that involve?
You'd need to break your documents down into smaller chunks of text,
Okay.
as processing an entire document at once would be too computationally expensive.
Right.
Then you'd use a pre-trained embedding model, similar to the ones we talked about earlier, to turn each chunk of text into a vector.
Okay.
Think of it like creating a fingerprint for each paragraph in your document library.
Okay, so I've chunked my documents, turned them into vectors. What happens next?
Next, you would create a Pinecone index, which is essentially a specialized database specifically designed to store and search through vectors.
Okay.
You would then upload all of your document vectors to this index.
Okay.
From there, you could start searching your document library using new queries.
So if I wanted to find documents about, let's say, the history of artificial intelligence, I would simply type in that query, and the system would convert it into a vector.
Yes.
Compare that vector to all the document vectors in my index, and return the documents that are closest in meaning to my query.
You got it.
Okay.
And because vector databases are so efficient at performing these similarity searches, you would get your results almost instantly.
Wow.
Even if your document library contains thousands of documents.
That's pretty amazing.
Yeah.
I'm starting to see how this technology could be used to create all sorts of interesting applications. It's like having a superpowered search engine that truly understands the meaning of your queries. This has been an incredible deep dive into the world of vector databases.
Yeah.
But I know we've only just begun to explore the vast landscape of this technology.
You've just scratched the surface.
What other exciting aspects of vector databases should we be thinking about?
That's a great point.
Yeah.
Talked about the basics of how these databases work and some of the exciting applications. But there's a whole other layer to this discussion.
Okay.
We need to talk about the challenges of working with vector databases. Especially when you're dealing with massive amounts of data.
Right.
Things like scalability, security, and optimization become crucial considerations.
Okay, so let's dive into that in part 2 of our deep dive into vector databases.
Sounds good.
We'll unpack some of those challenges and best practices.
Okay.
And I'm sure we'll uncover even more fascinating applications along the way.
I think we will.
Stay tuned.
All right.
Welcome back to our deep dive into vector databases.
Yeah.
Before the break, we were just starting to touch on the challenges and best practices associated with this technology. It sounds like when you're dealing with massive amounts of data, things can get pretty complex.
You're absolutely right.
Yeah.
It's one thing to understand the basic concepts of vector databases. Right. When you start thinking about applying them to real-world problems, especially at scale, a whole new set of considerations come into play.
Okay, so let's break it down.
Right.
What are some of the biggest hurdles people might encounter when working with vector databases?
Well, one of the first things to consider is that similarity search, the core functionality of a vector database, it's inherently different from traditional database searches.
Okay.
In a traditional database, you're looking for exact matches, but with vector databases, you're dealing with approximations.
I see what you mean.
Yeah.
We've been talking about finding items that are close to each other in this multidimensional vector space. But how do you actually measure that closeness?
Right.
Isn't that a bit subjective?
That's a great question.
Yeah.
And it brings us to the concept of distance metrics.
Okay.
Choosing the right distance metric is crucial for getting meaningful results from your vector database.
Distance metrics.
Yeah.
Can you elaborate on that a bit?
Think of it like measuring the distance between two cities.
Okay.
You could measure the straight line distance, or you could measure the distance you'd have to travel by car.
Right.
Taking into account roads and traffic.
Yeah.
Similarly, in a vector database, there are different ways to calculate how close two vectors are.
Okay, so it's not just about finding the points that are closest together visually.
Right.
It's about choosing the right way to measure that distance.
Exactly.
Based on the nature of the data and the type of similarity you're looking for.
Exactly.
Common distance metrics include Euclidean distance, cosine similarity, and dot product similarity.
Each with its own strengths and weaknesses depending on your specific needs.
Right.
Understanding these metrics and how they impact your search results is key to getting the most out of your vector database.
So if I'm understanding this correctly, the choice of distance metric is kind of like choosing the right map for a journey.
That's a great analogy.
You need to consider your destination and the terrain you'll be traveling through.
Exactly.
Yep.
And just like with maps, sometimes the shortest route isn't always the best route.
Right.
The same applies to choosing distance metrics in vector databases.
Okay, so we've got distance metrics to consider. What other technical aspects can trip people up?
Another crucial aspect is the indexing structure used by the database.
Okay.
Remember, we're often dealing with millions or even billions of data points in these databases.
Yeah.
Searching through all of them one by one would be incredibly slow.
Right.
That's where indexing comes in.
I remember hearing terms like HNSW and DISCAN mentioned in one of our sources.
Yeah, those are examples of indexing structures.
Okay.
And they can significantly impact the performance of your vector database.
Right.
Think of an index like the table of contents in a book.
Okay.
It helps you quickly locate the information you're looking for without having to read the entire book.
Yeah.
Similarly, indexing structures help the database quickly narrow down the search space and find the most relevant vectors without having to compare the query vector to every single vector in the database.
So it's all about optimizing how those millions of vectors are stored and accessed.
Exactly.
Right.
HNSW, which stands for Hierarchical Navigable Small World,
Right.
is a popular graph-based indexing method that's known for its speed and efficiency.
Okay.
Discanon, on the other hand, is designed for handling massive data sets that might not fit entirely in memory,
Right.
which is often the case when dealing with large-scale applications.
It sounds like choosing the right indexing structure is a critical decision. And it probably depends on a lot of factors, like the size of the data set and the speed requirements of the application.
You're absolutely right.
Okay.
And fortunately, many vector database platforms offer tools and configurations that help you make these choices without needing to be an expert in indexing algorithms.
Okay.
They allow you to fine-tune the balance between search speed and accuracy to meet the specific needs of your application.
Okay, that's reassuring to hear.
Yeah.
It sounds like there's a lot of complexity under the hood.
There is.
But there are also tools available to help manage that complexity.
Yes.
What about scalability?
Sure.
We've talked about how these databases are designed to handle massive amounts of data.
Right.
But what happens when your data set keeps growing? Or when you have a sudden surge in queries?
Right.
How do you make sure the database can keep up?
Scalability is a major consideration with vector databases.
Yeah.
As your data grows and the number of queries increases.
Right.
You need to make sure your system can handle the load without sacrificing performance.
One of our sources mentioned sharding and replication as ways to address this.
Yes.
Can you explain those concepts?
Certainly. Sharding is a technique for splitting your data across multiple servers.
Yep.
Think of it like having multiple librarians, each responsible for a different section of the library.
Okay.
This way, when you search for something, you don't have to look through the entire library.
Right.
You can just go to the relevant section.
Yeah.
Sharding allows you to distribute the workload and handle more queries simultaneously.
So it's about dividing and conquering, essentially.
Exactly. Yeah. And replication goes hand in hand with sharding.
Right.
Replication involves creating copies of your data on different servers.
So it's like having backup copies of all the books in the library.
That's a great way to think about it.
Just in case something happens to one of the copies.
Exactly.
Right.
Replication ensures high availability, meaning that even if one server fails, the system can continue to operate without interruption.
Got it.
It also protects against data loss, as you have multiple copies of your data stored in different locations.
Okay, so sharding and replication are essential techniques.
They are.
For building robust and scalable vector database applications.
Yes.
That can handle the demands of real-world use cases. We've talked about distance metrics, indexing structures, and scalability. Are there any other challenges or best practices to keep in mind?
Yes. Another important aspect that's often overlooked is data security.
Okay.
With all this talk about turning data into vectors, it's easy to forget that we still need to protect that data from unauthorized access and misuse.
That's a good point.
Yeah.
With all this talk about turning data into vectors, it makes me wonder about privacy and the potential for misuse.
You're right to be concerned about that.
Yeah.
Security is paramount.
Right.
Especially when you're dealing with sensitive information like personal data, financial records, or proprietary business data.
So what are some of the security risks associated with vector databases?
Okay.
And what can be done to mitigate those risks?
One potential risk is something called embedding inversion attacks.
Okay.
Remember how we talked about how embedding models create these vector representations of data?
Yes, I remember.
Kind of like fingerprints?
Yeah.
Well, researchers have discovered that in some cases, it's possible to reverse engineer those embeddings and reconstruct the original data.
Wait, so you're telling me that someone could potentially figure out the contents of a document or an image?
In some cases, yes.
Just by looking at its vector representation?
It's a complex process, but it's a real concern.
Right.
Especially when you're dealing with highly sensitive data.
So what can be done to protect against these types of attacks?
There are several approaches.
Okay.
One is to use encryption to protect both the data in transit and at rest. Encryption basically scrambles the data, making it unreadable without the proper decryption key.
So it's like putting a lock on the library door.
Exactly.
And making sure only authorized personnel have the key.
Exactly.
Got it.
Another important measure is to implement access controls.
Okay.
This means limiting who can view, modify, and delete data in the database.
Right.
You can also use techniques like differential privacy, which adds a bit of noise to the data to make it harder to reconstruct individual data points.
So it's about being proactive and having a security-first mindset from the very beginning.
Absolutely.
Yeah.
It's also important to carefully choose the embedding models and vector database platforms you use, making sure they have robust security features built in.
It sounds like security best practices are just as important in the world of vector databases.
You're absolutely right.
As they are in any other area of data management.
And as the field continues to evolve, we can expect to see even more sophisticated security measures being developed to address these emerging threats.
Okay, so we've talked about distance metrics, indexing structures, scalability, and security.
Right.
Are there any other challenges or best practices we should discuss before moving on?
Well, one more aspect that's worth mentioning is optimization.
Okay.
Remember how we talked about how vector databases use approximate nearest neighbor search, or ANN search?
Yes, I remember.
To find similar vectors?
Yeah.
Well, the efficiency of ANN search depends heavily on how the data is organized and indexed.
Okay.
There are a lot of different parameters and configurations that can affect search speed and accuracy.
Yeah.
And finding the right settings for your specific use case can be a bit of an art.
So it's not just a matter of setting up the database and letting it run.
Exactly.
You actually need to spend some time fine-tuning things to get the best performance.
You do.
I imagine this is where things can get pretty technical for someone who's not a data scientist or an engineer.
It can be.
Yeah.
But fortunately, there are tools and resources available to help. Many vector database platforms offer built-in monitoring and analytics tools that can help you identify performance bottlenecks and experiment with different configurations.
Okay.
There are also online communities and forums where developers can share tips and best practices for optimizing their vector database applications.
So it's really about staying informed and leveraging the available resources.
Exactly.
To make sure you're getting the most out of your vector database.
Exactly.
And as with any technology, the best way to learn is by doing.
That's right.
Don't be afraid to experiment, try different approaches, and see what works best for your specific needs.
I agree.
We've covered a lot of ground in this deep dive.
We have.
From the basic concepts of vector databases to the challenges and best practices for working with them. But before we move on to our final thoughts and wrap up, I know we have some listeners who are eager to hear about more real-world applications of this technology.
Yeah.
In part one, we talked about music recommendations, semantic search, and image search. But what are some other areas where vector databases are making a real difference?
Well, one area that's particularly fascinating is the use of vector databases in human trafficking detection.
Wow, that's incredible.
Yeah.
I had no idea vector databases could be used for something like that.
It's really interesting.
Can you tell us more about how that works?
Of course.
Okay.
Think about the vast amounts of data that are generated online and offline related to human movement, communication, and financial transactions.
Okay, I'm following.
Researchers are using vector databases to create representations of that data and then look for patterns and anomalies that might suggest trafficking activities.
Right.
For example, they might analyze travel patterns, communication networks, or financial transactions to identify individuals who are at high risk of being trafficked. Or to track the movements of known traffickers.
So the idea is to use vector databases to connect the dots.
Exactly.
And identify patterns that might be missed by traditional methods.
Exactly.
Yeah.
It's a complex challenge.
Yeah.
But one that vector databases are well suited to address by analyzing vast amounts of data and identifying subtle connections that might be missed by human analysts.
Yeah.
These systems could play a crucial role in combating human trafficking.
That's truly inspiring.
It is.
It shows that vector databases have the potential to be a powerful force for good in the world.
It certainly does.
Yeah.
And it's just one example of how this technology is being explored for social good.
Okay.
We're also seeing applications in areas like environmental monitoring, disease detection, and even personalized education.
It's clear that vector databases are rapidly moving beyond just tech buzzwords.
Right.
And into the realm of real-world impact.
They are.
I'm really excited to see what the future holds for this technology.
I am too.
I think it's safe to say we've both learned a ton about vector databases today.
I think so.
And I hope our listeners have too.
I hope so.
But before we let everyone go,
right,
I always like to end our deep dives with a little something to spark further exploration.
Okay.
And get people thinking about the possibilities.
All right.
What's one provocative question our listeners should ponder?
Okay.
As they continue their journey into the world of vectors.
That's a great idea.
Yeah.
A question to ponder.
Yeah.
Well, we've talked about how companies use vector databases to recommend things like music and products.
Right.
But what if you could use this technology to create your own personalized recommendation system?
Okay.
Imagine a vector database that knows your entire collection of books, movies, or even recipes.
Wow.
And can suggest new ones you might love based on what you've already enjoyed.
Ooh, that's a fantastic idea.
Yeah.
You could build a system that truly understands your tastes and preferences and helps you discover hidden gems you might never have found otherwise.
Precisely.
Yeah.
It's a fun and potentially very useful way to apply the concepts we've discussed today. And it highlights the power of vector databases to create personalized experiences that go beyond what's possible with traditional search and recommendation algorithms.
So to our listeners, we challenge you to think about how you might use vector databases to build something awesome.
That's right.
Maybe it's a personalized recommendation system.
Yeah.
Or maybe it's something completely different.
Mm-hmm.
The only limit is your imagination.
I agree.
And remember, the world of vector databases is constantly evolving.
It is.
New tools, techniques, and applications are emerging all the time.
All the time.
So stay curious. Keep exploring.
Yeah.
And who knows?
Right.
Maybe you'll be the one to make the next groundbreaking discovery in this exciting field.
You might be.
Well said.
Okay.
A huge thank you to our expert for guiding us through this deep dive into vector databases.
It's been my pleasure.
It's been a truly enlightening conversation.
Yeah, it has.
And to our listeners, thanks for joining us on this journey of discovery. We'll be back soon with another deep dive into a cutting-edge tech topic.
Okay.
Until then, keep learning, keep questioning, and keep pushing the boundaries of what's possible.
I agree.
That's what the deep dive is all about.
That's it.
That's such a cool idea. I can already imagine all the possibilities, but before we get too carried away dreaming up our own personalized recommendation systems, I think it's important to kind of step back and consider the bigger picture. You know, we've talked about the technical details of vector databases, the challenges, the best practices, and some of these amazing applications that are emerging. But what does all of this mean for the future? How will vector databases shape how we live and work and interact with the world?
That's the million-dollar question, isn't it? And I think we're just at the beginning. You know, we're really just scratching the surface of what's possible.
Yeah.
One thing that's clear to me is that vector databases are playing a key role in the rise of AI. By enabling machines to understand and process information in a more human-like way, they're paving the way for a whole new generation of intelligent applications.
You know, it's interesting to think about how our expectations of technology have changed over the years.
Yeah.
We used to be amazed by simple keyword search.
Right.
Now we're talking about machines that can understand meaning, intent,
right,
and even emotions.
Yeah.
It's like we're moving from a world of rigid rules and categories to a world of fluid concepts and relationships.
That's a great observation, and I think vector databases are a perfect example of that shift.
Yeah.
They allow us to move beyond the limitations of traditional rule-based systems and embrace a more nuanced, context-aware approach to information processing.
I'm really curious to see how this plays out in different fields. We've talked about music, search, even human trafficking detection.
Right.
But I imagine the implications go far beyond that.
They do.
What are some other areas where you see vector databases having a major impact?
Well, one area that I'm particularly excited about is scientific discovery.
Okay.
Imagine using vector databases to analyze massive data sets of scientific literature, experimental results, even genetic information.
Wow.
You could potentially uncover hidden connections and patterns that would be impossible to find using traditional methods.
Yeah.
This could lead to breakthroughs in medicine, material science, even our understanding of the universe.
That's mind-blowing. It's like giving scientists a superpower, allowing them to see the world in a whole new way.
It is.
And it's not just about analyzing existing data.
Right.
What about using vector databases to design new experiments, optimize processes, or even predict future outcomes?
The possibilities really are endless.
Yeah.
And I think we're just beginning to explore the potential of this technology.
So another area where I see vector databases having a huge impact is personalized medicine.
Right.
Imagine a world where treatments are tailored to your individual genetic makeup, lifestyle, and even your personal preferences.
Yeah.
Vector databases could help make that a reality.
For sure.
By enabling doctors to analyze vast amounts of patient data and develop highly individualized treatment plans.
Exactly.
That would be a game changer for healthcare.
It would.
Instead of a one-size-fits-all approach, we could have treatments that are truly optimized for each individual patient.
Right.
And it goes beyond just healthcare. I can see vector databases being used to personalize education, financial planning,
right,
even the way we consume entertainment.
Yeah, it's all about creating experiences that are tailored to our unique needs and preferences.
You're absolutely right. It's about moving from a world of mass production to a world of mass personalization.
I agree.
And vector databases are a key enabling technology for that shift.
I think so.
Okay, so we've talked about the exciting possibilities.
Right.
But it's also important to acknowledge that with any new technology, there are potential downsides and risks as well. What are some things we should be mindful of as vector databases become more prevalent in our lives?
One thing we need to be cautious of is the potential for bias in these systems.
Yeah.
Remember, vector databases learn from the data they are trained on.
Right.
If that data is biased, the system will reflect those biases in its outputs.
Yeah.
This could lead to unfair or discriminatory outcomes, especially in areas like hiring, lending, and even criminal justice.
That's a serious concern. It reminds me of the saying, garbage in, garbage out.
Exactly.
If we're not careful about the data we use to train these systems, we could end up with systems that perpetuate and even amplify existing inequalities.
Exactly. We need to be very intentional about ensuring that the data we use is a diverse, representative, and free from bias.
Yeah.
We also need to develop mechanisms for detecting and mitigating bias in these systems, even after they've been deployed.
It sounds like this is an area where ethics and technology intersect in a very profound way.
I think so.
We need to make sure we're using these powerful tools responsibly and ethically.
I agree.
Another concern that comes to mind is privacy. We've already talked about the potential for embedding inversion attacks, where someone could try to reconstruct sensitive data from its vector representation. But even if we address those technical vulnerabilities, there's still the broader question of how much personal data we're willing to share and how that data is being used.
That's a great point. As vector databases become more sophisticated and more integrated into our lives, we're going to have to grapple with some fundamental questions about data ownership, privacy, and consent.
Yeah.
Who has access to our data? How is it being used? And what control do we have over it? These are not easy questions, but they're questions we need to start asking now.
You're absolutely right. It's easy to get caught up in the excitement of new technologies. But we need to make sure we're not sacrificing our privacy and autonomy in the process. It sounds like navigating the world of vector databases requires a delicate balance.
It is.
Between embracing the possibilities and being mindful of the potential risks.
It's going to be a fascinating journey, and I'm excited to see how it all unfolds.
Well, I think this deep dive has given our listeners a lot to think about. We've explored the technical intricacies, the exciting applications, and the ethical considerations surrounding vector databases. It's clear that this is a technology with the potential to reshape our world in profound ways. Before we wrap up, I want to thank our expert for sharing their insights and expertise with us today. It's been an incredibly enlightening conversation.
It's been my pleasure. I'm always excited to talk about the amazing things happening in the world of data science and artificial intelligence.
And to our listeners, thank you for joining us on this deep dive into vector databases. We hope you've learned something new and are as excited about the possibilities as we are. If you're interested in learning more, we'll be sure to include some resources in the show notes. Until next time, keep exploring, keep learning, and keep asking questions. That's what the deep dive is all about.